Hi, welcome to this demo series on Red Hat OpenShift with Dell PowerStore Metro Volumes. In this first part, I'll provide an introduction to the solution and walk through the high-level architecture that enables high availability storage for OpenShift environments. Now, let's take a look at the purpose of this solution. The first goal of this solution is to ensure continuous storage availability for stateful applications running on OpenShift. Even during failures, the application should always have access to its data. PowerStore Metro Volumes provide an active-active storage architecture in which both PowerStore systems serve I/O simultaneously, eliminating single points of failure in the storage layer. Synchronous replication across the two systems ensures zero RPO, in which no data loss even if one system becomes unavailable. Every write is committed on both arrays before being acknowledged. The solution is designed to maintain operations during disruptions, such as OpenShift node failure, a storage path issue, or an array level event. The platform automatically redirects I/O to healthy paths or systems. Dell CSM Resiliency adds intelligence on top of Metro Volumes by detecting failures, fencing unhealthy nodes, and ensures workloads automatically recover or move to healthy nodes without manual intervention. Now, let's walk through the architecture overview to understand how the entire solution is structured. In this lab environment, all components, including the OpenShift cluster, the PowerStore systems, and the supporting services required for the solutions, are deployed within a single physical site. This setup is specific to the lab and does not limit the solution's ability to operate across multiple site architectures. At Site A, this lab uses a Red Hat OpenShift 4.18 compact cluster deployed on a Dell bare metal servers. The cluster is installed using the Red Hat Assisted Installer, which streamlines deployment and automates node bring-up. While the lab uses a compact topology, organizations can choose any supported OpenShift cluster architecture based on their requirement. Supporting services include DNS for name to IP resolution across the environment, NTP for time synchronization, and a bastion node that provides administrative access to OpenShift cluster. These infrastructure components ensure consistent networking, time accuracy, and secure cluster operations. Below the cluster, we have two PowerStore systems, System A and System B, configured with Metro volumes. Data is synchronously replicated across both systems, and System A acts as the preferred storage system. A PowerStore Metro witness runs in an independent fault domain and provides arbitration during system isolation events to ensure the correct array continues I/O. The overall topology follows a uniform access model. Each OpenShift node is connected to both PowerStore systems, giving workloads multiple active and standby I/O paths for redundancy. The integration between OpenShift and PowerStore is handled by the PowerStore CSI driver, which provisions and manages persistent volumes for container workloads. The Dell CSM Resiliency module adds intelligence to the environment by monitoring paths, handling fencing operations, and ensuring that workloads automatically recover during node or storage disruptions. Within the cluster, PostgreSQL is deployed as a stateful set, backed by PowerStore Metro Volume Storage. pgbench is deployed alongside to it to generate continuous database workload during the failover scenarios. This setup reflects real-world production workloads that rely heavily on reliable persistent storage. In addition to container workloads, OpenShift virtualization is enabled on the same cluster. This allows virtual machines to run alongside containers with the same platform. A Postgres virtual machine is also deployed using PowerStore Metro Volume backed storage. This VM is used to validate the same failover scenarios in a virtualized environment, mirroring the behavior we test with containers. From the cluster to the storage, networking, and workloads forms the foundation for the failover demonstration for both containers and virtual machines consuming the PowerStore Metro Volume.